Okay, let's start. So, um, part two, which is illumination techniques. I think I'll break this part two into two parts because it will be long. So let's move further and slowly. Okay. So basically, in case of illumination techniques, so roughly we divide in diffuse and direct, in which we definitely talk about parallel pipette, optical section, specular reflection, tangential illumination technique, conical definitely, and wide beam. I think there is very less difference between wide beam and optical, but yeah, a little bit different. Yes, then we will talk about indirect, proximal, retro, and sclerotic scatter, and we will definitely talk about retro in many different ways. So let's move forward further. So this categorization is a little bit rough, okay? So what is diffuse illumination? Diffuse itself, light is spread, isn't it? Evenly over the entire observed surface, basically means evenly to entire eyeball. So most often used in the slit lamp photography. So basically when we want actually external photography, then definitely we use this. So basically 45-degree angle and the full open slit. Whenever there is an angle, just remember, whenever there is an angle, it means it's an angle between illumination system and the observation system. Between that two vertical bars of microscope, bars of illumination system. Okay, and if no neutral density filter is filter diffuser, then decrease the intensity. What do you mean by, if you use neutral density filter, it will definitely going to decrease intensity, isn't it? That's what the work of neutral density filter, isn't it? Not selecting specific wavelengths, just passing through it. Neutral density filter is very useful in case of orthooptics in many cases, isn't it? It's a neutral density filter, and it's definitely useful in case of AVF. Yes, in many cases neutral density filter is very useful. So at least least amount of magnification. So definitely in case of diffuse illumination, we don't use high magnification, because in diffuse illumination we want gross rough structure. So that's how magnification is roughly 10x. The cobalt blue and red free filter also acts as a diffuser, but white light is generally used. So roughly we don't use that cobalt blue light and red free light, but we can definitely use these filters, but there is no restriction at all. But yes, definitely we use white light in general purpose. So what do you mean by that? I think you have seen such a thing in front of that mirror in any slit lamp. Just try to understand this. So this type of filter, this type of the glass, it will help to diffuse the light. Okay, you will see this type of lamp. So very rarely we use, but yes, we use sometimes, especially for photography, especially the general rough idea. So I have taken this picture from this book, very good book. I have taken a lot of pictures from this book in this presentation and the next presentation. Just remember, this book is gold. Okay, and this is a rough idea. Just throwing light here in eyeball, and it's look like this, isn't it? Just rough structural thing, gross. Okay, I've also taken this book, this picture from this book. So diffuse illumination, it's rough, diffuse, you can see all over. And observe basically eyelid, eyelashes, conjunctiva, sclera, pattern of the redness, iris, pupil, gross pathology or media opacity, or especially useful in contact lens treating. We use roughly, okay? So it's just a rough diffuse illumination, just a simple thing. So let's move forward. What is direct illumination? So you see direct illumination and indirect illumination. One thing that distinguishes between direct illumination and indirect illumination means observed and illumination system focus at the same point. That's the basically direct illumination. So observation system and illumination system, where we throw the light, we are seeing exactly that particular area of the eye. That means direct illumination. Indirect illumination, we throw light at another place and we actually looking at another place. Those two places are not same. But in case of direct illumination, observation system and the illumination system focuses at the same point, isn't it? That's what we so-called principle of slit lamp, because we many times it's called, we call coaxiality is the principle of slit lamp, and that's what actually direct illumination means. So direct illumination means you throw the light at the same place and you observe that very same place. So angle, very angle is vary the angle of illumination. It's definitely vary the angle of illumination. Variable magnification is used. Yes. Variable width and the height of height is, see, width and height is used. Yes, it's dependable the particular type we are using direct illumination, but definitely it's dependable our choice also as an clinical as clinician, as a optometrist, or as an ophthalmologist. Okay, so roughly, direct illumination is categorized in broad beam, optical section, parallelepiped, conical beam. Okay, roughly. This is all. We throw light at this particular area and we observe this particular area. So that's in this picture. Can you see? Okay, it's blue and blue. It's difficult. So we are throwing light here in this particular area of the cornea, and we are seeing that particular area of the cornea, isn't it? Okay. This ray actually cornea is transparent. That's why it is shown like that. Okay. So broadband illumination means, what is broadband? Now come to four. Large area to examine large area. It's simple, simply that. We don't use diffuser here. We simply do a broader beam. Okay, broader beam. We do not use like something like small focus point, but a very large broad area, and we focus on the very broad area through microscope too. And the light thrown and what we have seen in visible, seeing through the microscope, are same. That's why it's direct illumination. So I can say it's broad, but it's, yes, not broad like something like parallel pipette. But can you see this area? Very good optic, very good. What do you call this? Isn't it prominent corneal knobs? These are prominent corneal knobs. Okay. So can you see here? What is this? Lenticular structure, isn't it? So basically, this is the roughly broad, but yes, sometimes we call it parallelepiped too. What is parallelepiped? So broader view, illuminated block of cornea, angle viewed the system roughly 40 to 40 50 degree between illumination and observation system, definitely slit with roughly 1 to 2 mm, and provides a layer view of the cornea and the lens. So just remember, whenever you try to see the layer view of the cornea and the lens, I don't know, parallelepiped is good, yes, but definitely optical section is the great, because I love optical section. I'll show you later. So high magnification, then the width beam to evaluate the depth and the extent of the aberration or scar or foreign body. So basically means high magnification is used whenever you want to see the layer by layer, isn't it? So basically that. So in case of parallelepiped means a slide. That's what we know till now. Okay. So observe corneal stroma epithelial background. Okay, it takes fine. Let's move forward. So basically means this. Whenever you show the cornea, you should see cross section. Okay, that's what parallelepiped means. So I have taken this picture from this book, which is Optical Devices in Ophthalmology and Optometry. So optical section, and this is what I'm very big fan of. So basically, what is optical section? Optical section means the smaller, finer version of parallelepiped, I think so. So narrowed focus light. So width is very small, 0.25, less than 0.25 word. Yes, it's roughly that. So it's very important whenever you want to see the depth in layers. Okay, localized nerve fiber, blood vessels, uh, so infiltrate cataract, anterior chamber depth. So what do you mean by that? It basically means optical section is used to evaluate structure of corneal lens and good judgment of the depth of corneal foreign body and position of cataract. That's gold. So good judgment of corneal depth of corneal foreign body. Whenever I was in a clinic, or I was basically or university hospital, and whenever I'm teaching student how to remove foreign body, I always teach them, just do optical section, and first you understand where that foreign body is, because I was in third year student back then, and then I saw the foreign body and I looked through the corneal sorry optical section, and I feel that it's deeper. And then when I showed to my faculty, cornea specialist, he said that yes, we have to remove it in operation theater, because it was deeper foreign body and metallic foreign body. So that day I was prevented from the blunder, isn't it? So that's very important. If I try to prick that particular foreign body, then would be okay. I just think that that was a very good lesson I have learned optical section. Okay, that's very important whenever you are looking to foreign body and you know which layer of the cornea that foreign body is. It's very important. And I know whenever you try to look at cataract and you try to want to understand in which depth cataract is, that particular uh, cataractus mass is. Okay, so it's very important. So I'll show you picture. See, this is the gold. Okay, see, whenever the angle between observation system and illumination system is small, it's difficult, isn't it? It's very difficult. But see, in this case, illumination observation system, there is a good amount of angle. Can't you see this is anterior cornea and this is posterior cornea? This and throughout the layer, isn't it? In this picture, can't you see this layer? So that's what very important optical section is, gold. And whenever you fit a scleral lens depth, you it's optical section. It's very helpful whenever you fit contact lens. It's very helpful. Even in RGBs, it's very helpful. Okay. So can you see this picture? This is posterior segment. See, posterior is roughly very rough, isn't it? I have taken this picture from this book and this picture from this book. Can you see this? See, nucleus is sclerosis, and you can even observe the layers of the lens here and here, pseudophakic, isn't it? Here, cornea, and you can see cornea here clearly. Cornea here, depth you can analyze, isn't it? In this picture, can't you analyze the depth? Can't you analyze the depth? It's very important. Okay. So it's basically nuclear viscous cataract and optical section through the young transparent lens. And to see the young and trans, I'm sorry, I have told you that pseudophakic lens. It's young and transparent lens. Yes. So now come to conical illumination. What is conical illumination? So basically means it is produced by reducing the height of parallelepiped. Okay, first. Second is square spotlight in dark room to examine AC cells and flares. So conical section, whenever this term conical section comes, I always think about AC cells and flares, isn't it? In enterouveitis, definitely. So what? Try to understand conical section like this. This is the gold picture I have taken from the book referenced below. Very good book. So in this particular, can you see the rays of light? It's not you are seeing the rays of light, it's you are seeing the dust over there. And the background is actually darker, this background, isn't it? Which is very helpful to understand this concept. So whenever you throw a small amount of light, narrower light, it's a Tyndall effect, isn't it? Then you can see cells like this in interior chamber. What is the goal that you have to understand is the background must be dark. It's very important. The background is dark, isn't it? Background must be dark. And you focus on the anterior chamber with this microscope and light thrown by side, and just understand the background. If you throw it to iris, definitely that background is dark. The background towards the retina. So background is basically because of there is no light in retina. You throw the light to iris, or you angled so much that background is dark, and that dark background you will definitely see uh, what do you call that, cells and flares. It's very important. Okay, just try to grab this book and see all the pictures, which is very helpful pictures. So can you see in this picture, it's very, isn't it? 4 plus cells, a lot of cells, isn't it? And see, in this case, 4 plus cells, it's like flare, isn't it? My goodness, it's very important. It's again the same book. Okay, so I think that's it. I'll definitely talk about retro illumination, indirect illumination, swinging illumination. I'll definitely going to talk about this three illumination in next video, because I want to break it, because it will eventually it will be longer if I'm not going to break it. Okay. Again, I want to tell you that my references are very gold for you always. These are my references. This is great book. I have taken a lot of picture from this. reference, lot of pictures, and I fall in love with this book and the pictures it has. And definitely this book is also good. This book is also good, but a limited amount of information about slit lamp. But the information about slit lamp magnification is very good in this book, in the last book. And other information like clinical tips is very good in this book, or particularly the slit lamp applications for microscopy. Okay, this book is very good for the uh, tips of slit lamp, and this book is very good for the concept of illumination, concept of everything. If you want concept, this is great book. So I think that's it for today. I will discuss definitely about more illumination technique in later videos. Okay, so bis dann, tschüss.